So today's topic is what? Atom and waves. Voice and everything clear? Okay. So first, atom, most of the student is comfortable. Only few things in the atom first I will complete because it is a small chapter, I can complete early, and then after that, according to the time, then we will go to the wave. Okay. Okay. So first thing in the main things like whatever chemistry also we have completed the atom. So mainly what is the different in the physics atom, which type of question they can ask in the physics that they are not asking in the chemistry. Okay, so all formula of the radius, energy, time period, all be marked up in the atom. Okay, but all formula how we derive. So basically that we have to know in the physics means how all those formula, radius formula, maybe you have learned the value of radius in any orbit 0.529 n square by z angstrom. You have learned energy formula, you learned E is equal to minus 13.6 into z square by n square electron volt. Okay, all this formula we learned, but how these values came, how this formula come, that you have to know. Okay, so we have to remember what we are using, the two principle or two relation to derive the formula of the radius, to derive the formula of the energy. Okay, what are those? One is what? Electron is performing in the atom, electron is performing circular motion. Okay, in the circular motion some force has to be there towards the center, some force should be there towards the center, that force is a centripetal. Okay, so one relation we will get what? In atom what is happening? Electron is experiencing the force due to the nucleus. So nucleus positive charge is applying the force towards itself. It means electrostatic force is the centripetal force. Electrostatic force is the centripetal force. One relation that, okay, force relation is what? Which force is acting towards the center, that is a centripetal. Okay, so one relation we will use force relation, other we will use Bohr quantization. Bohr quantization. Okay, so one formula force is what? Mv square by r, because force will be equal to conservative force is equal to centripetal. Okay, next is what? Bohr quantization. What is the Bohr quantization? mvr is equal to nh upon 2 pi. That is the second relation. By using all these two, we have derived the formula of the radius, we have derived the formula of the energy, we have derived the formula of the time period. In actual atom, whatever we are dealing, which atom we are taking, in that atom electrostatic force, conservative force is what? Electrostatic. So electrostatic force, what we can say? 1 by 4 pi epsilon naught z into E square by r square is equal to what? Mv square by r. K q1 q2 by r square, that is equal to centripetal mv square by r. Now here two variables are there, v and r. V and r. Suppose V I am taking from here, finding from here and putting in the second equation, first equation, we will get the radius formula. After getting radius formula, we will get the velocity formula. Okay. So by using these two, we can derive all. So already we have learned the formula of the radius, energy, time period. Okay. So I'm not going to those questions because already everybody is comfortable how radius depends upon the n, how radius depends upon, how energy depends upon the n. Okay. But suppose they are changing the force function, they are considering any hypothetical atom, force function they are changing, then what is the effect on the radius, what is the effect on the velocity, what is the effect on the energy? 2, 3 year, 4 year, they ask the question based on that. Okay. So suppose I am saying in atom potential energy, if I am giving U is equal to minus CR, where R is the radius of the orbit. Okay, then how the R depends upon N. R and energy are directly proportional to N square, energy inversely proportional to N square, one option. Second option, R directly proportional to root N, energy inversely proportional to root N. Next, suppose I am saying R directly proportional to n to the power 2 by 3 and energy is directly proportional to R to the n to the power 2 by 3. Like these options I have given. Fourth option, suppose I have given none. What is the right answer? First, okay. This U is the what? Potential energy. Potential energy I gave U is equal to minus CR. I am saying in this atom how, and assuming Bohr quantization applicable, how the radius will depends upon the n and energy will depends upon the n. Somebody gave the answer 1. Any other? 1. Okay, 1. Okay. 1, okay, 1, okay, 1, okay, 1, 1, 1, 1, 1. Okay, Miss Moose, all of you are giving the answer 1. Somebody is giving the answer 1 only, I got answer 3. Now listen, maybe you have not done this year NEET question also. This type of question, what we will do, what I said, potential energy, if you have mucked up the potential energy formula in the atom, and now you have completed the electrostatics also. In the electrostatic, what is the electrostatic potential energy? 1 by 4 pi epsilon naught Q1 Q2 by R. In the atom, potential energy of the electron you have learned 1 by 4 pi epsilon naught ZE square by R, ZE square by R with minus sign. So minus 1 by 4 pi epsilon naught ZE square by R. That was the potential energy of the electron in the atom. Kinetic energy, half of that, but positive. And total energy formula you have learned minus and equal to the mod of K. This I think everybody remember. Mod of potential energy is the double of kinetic and total. Kinetic and total. Okay. So there we got the potential energy inversely proportional to R. We are using we have made this graph also in the actual atom. This graph you have made. This is the R, this is the E. So which energy is the kinetic? First one is the kinetic because kinetic is positive. Total and potential is negative. That's why this 2 and 3. One is the potential, one is the total. Which one is the potential? Which one is the total? So potential energy is more negative because we have got the formula for potential energy is what? Minus 1 by 4 pi epsilon naught ZE square by R. Total energy what we are getting? Minus 1 by 4 pi epsilon naught ZE square by 2R. So 2 is the total because less negative, total, more negative, potential, positive, kinetic. Okay. So in the actual atom, what we have learned, potential energy is inversely proportional to the R. But here what I gave? Here I gave U is equal to minus CR. U is equal to minus CR means potential energy is directly proportional to R. It means it is not that atom. It is not the actual atom. So what I said, all formula, radius, energy, all relation, we will derive by using two relation. One is the force, other is the Bohr quantization. Okay. Now first, how we will get the force for this? So force and potential energy, what is the relation? F is equal to minus du by dr. So F is equal to what? Differentiation when you will do, then what you will get? C, where C is the constant. So force what we got? Constant. This year in the NEET also they asked, electron, a constant force is acting towards the center, then how the radius will depends upon the n and energy will depends upon the n. Same question they asked this year. So force we got what? Constant. And force will be equal to what? mv square by r. So what I said, one relation is for force. Okay. F is equal to mv square by r. Second, Bohr quantization. mvr is equal to nh upon 2 pi. That is the second. Okay. Now from the first, I need the r. I don't need v. So how I can replace the v? V square is directly proportional to r. So V I can write what? I can write V square directly proportional to R. It means what? V is directly proportional to under root R. So V I can replace proportionality, I can replace with root R. Now here MVR. M will go to the proportionality. V I can replace with root R. Root R V root R into R. Here directly proportional to N. Then I can say what? R to the power 3 by 2 is directly proportional to N. Then take the power 2 by 3 on both sides. So R directly proportional to N to the power 2 by 3. So how the radius depends upon the N? R is directly proportional to N to the power 2 by 3. This everybody got or not? Now R this we got. Then energy. Here you can see energy what I gave. U is equal to minus CR. So by this relation I can say U directly proportional to R. U directly proportional to R, and energy directly proportional to R. R directly proportional to N to the power 2 by 3. So it means I can say what? Energy directly proportional to R. So energy is directly proportional to N to the power 2 by 3. So energy and R both will depends upon directly proportional to N to the power 2 by 3. Completed. Okay. So what I said, if they are changing the force function, they are giving the hypothetical atom, then we have to think these two equations to derive the R, energy, anything they are asking, we can derive by using these two. Okay. So this type of problem complete. Second, suppose I am saying in any hypothetical atom I am considering, in that atom, electron, in the place of electron, any other charged particle is revolving. Same atom structure, everything same. But in the place of electron, we are taking any other hypothetical atom we are considering. In place of electron, other charged particle is revolving, whose charge is same as of electron. Whose charge is same of electron. Okay. Sir, one more question. Okay, I will give, wait. What I said, in the place of electron, any other charged particle is revolving, but the mass is double of electron. Then what will be the effect on the Bohr radius? First Bohr orbit, what will be the effect? Again I am repeating, if the electron in the hypothetical atom, in the place of electron, we are taking the another charged particle whose charge is same but mass is double of electron. Then what is the effect on the first Bohr radius? Suppose in the hydrogen atom I am saying, what is the effect on the first Bohr radius? So who has mucked up the formula? R is equal to 0.529 into N square by Z. So they will think here mass of the revolving particle is not coming. It means whatever the particle mass they given doesn't matter. Radius will be constant. But how we got this 0.529? This formula we learned now, R is equal to 0.529 into N square by Z angstrom. So in this formula, this 0.529 angstrom, how we got? By using the mass of electron. After putting the mass of electron, this constant, this is not the universal constant 0.529. This constant we got by putting the mass of electron. Okay. But now in the place of electron, mass of the particle is double. So this is the question in the NCERT given, also additional exercise, and in the NEET also 2017 they asked the question directly. Muon they asked. Muon mass is the 207 times of mass of electron. Then what is the effect on energy and the radius? So if they are changing the mass of revolving particle, charge they are taking same. So just remember that. Radius we will say what? Whatever formula you learned upon mu. What is the mu you will take? Mu is the mass of particle upon mass of electron. Okay, that one term I am defining. Mu. Mu is what I am taking? Mass of particle, whatever they given, upon mass of electron. Like mass of particle is double of mass of electron. So 2 me upon me, 2. It means that formula, whatever you mucked up, that you will divide with 2. For energy, what we will do? E dash is equal to E into mu. E dash is equal to E into mu. For velocity, velocity will remain same. Velocity doesn't depend what is the mass of the revolving particle. Double, triple, whatever they do, velocity formula will remain same. Everybody got or not? So R dash, R by mu, energy E dash is the E into mu, and velocity will remain same if they are changing the mass of revolving particle. You will remember, like for the muon. So more for the muon, they given mass of the muon is the 207 times of mass of electron. So what is the mu you will get? Mass of particle 207 me upon me. So mu value you got 207. So radius formula, whatever we mucked up, upon 207. Energy, whatever we remember, into 207. Everybody got? Not understood? Should I repeat again? So I think this question you have done. It is an NCERT additional exercise question also. Okay. Okay then. So whose thumb is down? What is the problem with them? Should I repeat or now it is okay? Everybody understood? What I said, if they are changing the mass of revolving particle, then in the place of electron, any other particle they given, then what we will do? First, we will find the ratio, this ratio. What is the ratio I defined? Mu. What is the mu? Mass of the particle upon mass of the electron. It means first we will define the ratio. After that, whatever radius formula you learn, that radius formula you will divide with mu. Whatever energy formula you learn, you will multiply with mu. Okay. What is the minimum excitation energy in the hydrogen atom? Who will say? Minimum excitation energy in the hydrogen atom. Minimum excitation energy in the hydrogen atom. Minimum excitation energy from hydrogen atom. 13.6 minus 13.6. 13.6. So most of them minus 13.6 plus 13.6. Okay, minus 13.6 plus 13.6. 13.6. Okay. Now listen, that is the ionization energy, Nalayak. It is the ionization energy. Excitation energy and ionization energy is the different. Ionization energy definition you learned. Energy required to remove the electron from gaseous hydrogen atom. That is called the ionization energy of hydrogen. But I am not asking the ionization energy. I am asking excitation. Excitation means you have to excite the electron. You don't have to remove the electron. Okay. When we want to remove the electron, like a escape velocity, escape energy. Escape energy means you want to escape the body. Same way you want to escape the electron. So that is ionization. Here excitation means electron will go to the excited state. So what is the minimum energy of excitation in the hydrogen atom? So excitation energy means this energy level you have to remember. What is the energy of the first orbit? Minus 13.6 into Z square. I am taking any other atom also, suppose they given, so into Z square. Hydrogen like atom, but the atomic number is not 1. So minus 13.6 into Z square. It is the first orbit energy. Second orbit energy, minus 3.4 into Z square. Because you will divide with N square. Third, minus 1.5 into Z square. Fourth, minus 0.85 into Z square. Fifth, minus 0.5 into Z square. Okay, at least up to the 5, you have to remember the values. These are the energy of the different orbit. If the atomic number they given the different like He plus Li plus 2, then we can multiply with the Z square. Okay. Now, minimum energy of excitation means what? One thing we have to know, excitation will always take place in the ground state. Okay. excitation we will always consider in the ground state, because electron will absorb the energy in the ground state. It will not absorb the energy in the excited state. Okay, so ground state it will absorb. Now at least what is the minimum requirement? It will go first orbit to the second orbit. It will go first orbit to the second orbit. Okay, so second orbit means what is the energy difference between first and second? That is a 10.2 into Z square. Hydrogen atom, then we will say the 10.2. For any other atom, multiply with Z square. So minimum it will go from first to 2. So that is a minimum energy of excitation. What is the minimum energy of excitation? 10.2. For hydrogen atom, 10.2 eV. For any hydrogen like atom, 10.2 into Z square. Okay. Similarly, 1 to 3. 1 to 3. How much energy difference will come? That is a 12.1 Z square eV. So for hydrogen atom, 1 to 3, how much energy? 12.1. 1 to 4. 1 to 4, what is the energy required? That is a 12.75 Z square. At least up to these energy you have to remember. Everybody got or not? These are the excitation energy. These are the excitation energy. So first excitation energy 10.2. Second excitation energy 12.1. Third excitation energy 12.75. So what is the minimum energy for the excitation? 10.2. 10.2. At least it will go from the first orbit to the second orbit. Okay. Got it or not? And remember that absorption will take place always in the ground state. It happen in the laser, but that is not in our syllabus. We don't have to know even. So what I said, excitation always take place in the ground state. So excitation or absorption spectrum will always belongs to the Lyman series. Again, I am repeating the statement. Absorption will always take place in the ground state. Absorption will always take place in the ground state. Excited state absorption will not take place because excited state is very short duration. Okay. In numerical particularly they mention, then it is okay. Otherwise, theoretically, we are not considering the absorption in the excited state. That's why absorption spectrum will always belongs to the Lyman series. Why? Ground state to the any excited state it will go. Ground state to the any excited state means absorption will take place at ground state. So absorption spectrum always belongs to the Lyman series. Absorption spectrum always belongs to the Lyman series. Got it? Completed? Suppose electron de-excite from the higher energy level to the higher energy level n. Electron de-excite from higher orbit n to the ground state. To the ground state. This formula I think everybody remember. How many lines we will get in emission spectrum? How many lines we can get in the emission spectrum? How many lines we can get in the emission spectrum? If electron higher orbit n to the ground state it is coming, then what is the formula for the number of a spectral line? N into n minus 1 by 2. Yes, a spectral line we can get n into n minus 1 by 2. This is the total number of the spectral line if I have given the higher orbit n, like 4 to 1, then I can say total number of spectral line possible is what? 4 into 4 1 minus 1 3. 4 3s are 12 by 2 6. So we can get the 6 line, and I can show also like how 6 line. Suppose I am taking 1 2 3 4. So electron is coming from fourth excited state to the first ground state. Then like one line, it will come first 4 to 3, then 3 to 2, then 2 to 1. How many lines are possible? 3. Another possibility is what? Electron will come from 4 to 2, and then it will emit the photon, and then it will come from 2 to 1. 2 to 1 already I have taken. Okay, so 4. Next possibility is what? Electron is coming from 4 to 3. 4 to 3 already I have taken. Then directly 3 to 1. This is the another possibility. This is the different line and different energy photon basically. Okay. Other possibility is what? Directly it will come from the 4 to the 1. So how many transitions are possible? 6. So how many spectral line we can say? That is a 6 spectral line we can get in this case. So basically spectral line is what? Different energy photons we can say. Different energy photon. Like 4 to 3 photon energy, 3 to 2 different photon energy, 2 to 1 different photon energy, 4 to 2 different photon energy. And we know that energy of photon will be equal to the energy difference between the orbit in which electron is transiting. Like electron is coming from 4 to 2. So whatever the energy difference is there, it will emit the photon. If it is coming from 4 to 1, so whatever the energy difference is there, it will emit the photon. Like 4 to 1, what is the energy of the photon? 12.75, just now I said. If electron de-excite from 4th to the first orbit directly, what is the energy of the photon emitted? 12.75. If it is coming from 3 to 1, what is the energy of photon emitted? 12.1. Okay. Completed. Suppose I have shown the 4 lines. In these 4 lines, which photon has the maximum energy? Which photon has the maximum energy? A, B, C, D, 4 photons suppose I have shown. Which photon has the maximum energy? One answer I got, D. Then C, D, A, C, A, D, D. Most of the people are giving answer D. Now like, let's listen. When the first orbit will involve, always we have to check the energy of that only, because the first orbit, you can see now, first and second orbit difference is the 10.2. First and second orbit energy difference is 10.2. After that, second orbit to the infinite, energy difference is 3.4 only. Again, I am repeating. First and second orbit energy difference is what? 10.2. Just now I said. Okay. Second orbit energy is what? 3 minus 3.4. So second orbit and infinite, up to the infinite orbit, what is the energy difference? 3.4. And that difference of energy is lesser than the energy difference between 2 and 1. So when the first orbit is there, first orbit means one line is in the first orbit, always its energy will be maximum, only those energy we have to check. Suppose here I gave the 2 lines, that is coming to the ground state. Suppose one line is this, one line I have given this. Suppose E. Then I can say the energy of E is maximum. But if I have not given, because now I have to only see these 2 lines, because they are coming to the ground state, suppose. So here, this energy difference and this energy difference is more. Then I will go to the E. But here, what is the answer? What is the answer? C. C will have the maximum energy. C will have the maximum energy. Everybody got or not? So this point you have learned. When we are going to the higher orbit, energy difference between the consecutive orbit decreases. Energy difference between the consecutive orbit decreases. Like first and second 10.2, then second and third around 1.9. So means energy difference will continuously decrease. Okay. So C will have C energy maximum. Tell fast. If lambda is equal to 975 angstrom, that is the radiation absorbed by the hydrogen gaseous atom, then what are the possible line in the emission, number of the possible line in the emission spectrum? Number of possible line in the emission spectrum. So first thing, Electron absorb the photon. What is the energy of the photon? 970 wavelength of photon 975 angstrom. It absorbs. First thing, maybe if suppose they are saying no absorption spectrum, no emission spectrum. So first we have to find the energy of the photon. If the energy of photon is equal to the difference of energy between any first and any orbit, then the photon will get absorbed. Otherwise, photon will get completely rejected. Listen, again I am repeating, with photon, that maybe you have learned also, with photon and electron and any other particle even. Photon, when it is colliding with electron or any other particle, only two type of collision is possible. Only two type collision possible. When a photon collide with a electron, either means perfectly elastic or perfectly inelastic. Perfectly elastic or perfectly inelastic. It means either the photon will get completely absorbed or photon will get completely rejected. So with electron and photon, only two type of collision is possible. Either photon will get completely absorbed, means whole energy will go to the electron, or photon will get completely rejected. That was that concept we have learned in the photoelectric dual nature also. Okay. So with photon and electron, only two type of collision is possible. Either the photon will get completely absorbed or photon will get completely rejected. Okay. So first what we will do, we will find the, if they given the wavelength of the photon, first we will find the energy of the photon. After finding the energy of photon, if that energy belongs to the energy difference between the first and the any other orbit, then it means it will absorb and jump to that orbit. But suppose that energy is not equal to the energy difference between the first or any other orbit, it means that photon will not get absorbed, no absorption, no emission. Okay. So first I will find the energy of photon. So what is the energy of photon? 12,400 upon lambda in angstrom, that is the 975, the energy you will get in EV. Okay. So this will come what? 12.75 approx. 12.75 EV. So it means energy of the photon is 12.75 EV. So where the electron will jump? It will absorb this photon or not? Yes, it will absorb the photon. Why? 12.75 is the energy difference between the first orbit and the third orbit. Okay. So it will absorb. So what is the higher energy state? N2 we can say 4. N1 is equal to what? 1. From the 1 it will go to the 4. Now excited state is very short. It will come back to the ground state. Then how many spectral line we can say? Lines we can say what? Higher orbit is what? N. N is the 4. So 4 minus 1 into 2. So that will be equal to what? 6. So how many lines we can get in the emission spectrum? 6 lines. Completed. Okay. If suppose I am saying it is a hydrogen atom, in this emission spectrum, what is the maximum energy photon and what is the minimum energy photon? In this emission spectrum, what is the minimum energy photon and what is the maximum energy photon? What is the minimum energy photon and what is the maximum energy photon? What is the minimum energy photon and what is the maximum energy photon? Minimum is 10.2, maximum is 12.75. Any other answer? Minimum somebody is saying 10.2, maximum they are saying 12.75. Any other answer? In this emission spectrum, what is the minimum energy photon? Minimum 13. Wow, nalaik. Absorb is the 12.75. Minimum it will give 13.6. Very good. Minimum 10. 10 maximum 10.2. Maximum 10.2. One thing, directly don't think like what you are thinking. Problem, what they are asking, at least just give some time to think what is the meaning of the problem. Randomly few values we have mugged up, 13.6, 10.2, means question is whatever, we will put that answer only. Use the brain. What is the question asking? Question in this question, what I am asking? Minimum and maximum energy photon. Spectral line is basic. Maximum, how it can give 13.6. You are absorbing less, but you are giving output more. Means your electron is producing the energy. Bhargavi, is it possible? Electron absorb 12.75, but it is giving 13.6. Now our energy problem solved. Electron is absorbing less, but giving more. Is it possible? So answer means at least question meaning you have to understand. I said what? What is the meaning of the spectral line? Basically these are the photons. These are the photons. Now electron is de-excited from fourth to the first. Okay. I have shown the lines. I have shown the 6 lines. Okay. Just previous slide. In this 1, 2, 3, 4 and this 5, this 6. These are the 6 line I have shown. Okay. Now I said what? When we are increasing the orbit, when the n value increases, then difference between the consecutive orbit energy decreases. Difference between the consecutive energy decreases. So in this, what is the minimum energy photon? Suppose I have represented like this. Another, I have make the figure this. One, 2, 3, 4, 5, 6. In this 6 photon, what is the minimum energy photon? What is the minimum energy photon? 1, 2, 3, 4 number I gave. Which photon has the minimum energy? 1. Why? Because when we are increasing the number of orbit, n value increases, difference between consecutive orbit decreases. Okay, so 1 has the minimum energy. Which has the maximum? Which has maximum? 6 has maximum. Okay, what is the energy of the 1? Energy of the 1 is difference between the 4th and 3rd orbit. Difference between the 4th and 3rd orbit. What is the 3rd orbit energy? I said 1.5, and the 4th orbit energy, what I said, 0.85. What is the difference? 0.65 approx. Okay, so what is the minimum energy photon? 0.65. 0.65. That is the corresponding to the 1. And what is the maximum? Maximum is from 4 to 1. That is the maximum energy photon. What is that energy? Whatever absorbed, that emitted, 12.75. So maximum energy photon 12.75, minimum energy photon corresponding to 4 to 3. That is what? 0.65. So minimum energy photon 0.65, maximum energy photon 12.75. Everybody got? Okay. Now suppose I am saying another problem. 12.5 electron volt photon beam incident on hydrogen atom. Then how many lines we will get in the emission spectrum? If the photon beam of energy 12.5 electron volt incident on the or pass through the gaseous hydrogen atoms, then how many lines we will get in the emission spectrum? How many lines we will get in emission spectrum? Happy Pongal to all. Somebody sending the message. Okay. How many lines we will get in emission spectrum? 1. I'm not asking absorption. I'm asking in emission. 3. Okay. 3. 1. Both side answer is this side also, this side also. Okay. 3, 2, 3, 2, 1, 0. Satellite launch. Okay. So 1, 6. Wow. 6, 3, 3, 3, 2. Okay, now listen. 4 also. Okay, 4 was missing because in between 1, 2, 3, 6 came 4 was missing. Okay, somebody 5, 10 also. Okay, very good. 2. Answer is no absorption, no emission spectrum will obtain. No absorption and no emission spectrum is obtained. No absorption and no emission spectrum obtained. Just now, what I said. With photon, only 2 types of collision is possible. With photon, 2 types of collision is only possible. Either photon will get completely absorbed or photon will get completely rejected. Photon will get either completely absorbed or photon will get completely rejected. What is the energy of photon? 12.5. Now 12.5 absorbed by the electron. So where the electron will jump? If your electron is leaving its home ground state, so it has to get some home to land, but after absorbing 12.5 any energy level is there where it can jump? No. Why? First to second 10.2, first to 3 12.1, first to 4 12.75. so after absorbing 12.5 there is no energy where electron can jump. So that's why no absorption, no emission. Understood or not? Okay, in NCERT exercise they given, in the place of photon beam, then it can stop at third orbit. How it can stop at third orbit? But approximate, electron will adjust. Electron will say, please adjust my energy and please give the place to in your home, na? Electron will request to the third orbit. My energy is slightly lesser, so please give the place. That is approximation and request will not be there in the case of the electron. Means electron will request us. Okay, so it will be there only when it has energy belongs to that orbit. That is called the quantization of the energy. Okay. No, means your electron can request also, na? Okay. So here one thing for the photon beam, no absorption, no emission. Okay. In NCERT, they given this question for the electron beam. Suppose in the place of photon beam, I am giving electron beam. Then what is the how many lines we can get in the emission spectrum? How many lines we can get in the emission spectrum? In the place of photon beam, I have given the electron beam. Then how many lines we can get in the emission spectrum? 3, 0, no lines. 0, 0. Here we will get the line. Now listen, you have learned the collision chapter, completed or not? In collision we have what I said, with photon only 2 types of collision is possible, either perfectly elastic or perfectly inelastic. It means either photon will get completely rejected or completely absorbed. Okay. In the case of the electron beam, now this electron beam is what? Colliding with electron. So between the two body, how many collisions are possible? Infinite collisions are possible. Why? Like 2 blocks are colliding with each other perfectly elastically, perfectly inelastically. E is equal to 0.1, E is equal to 0.5, E is equal to 0.2, E is equal to 0.6, E is equal to 0.65. Any coefficient of restitution E means any type of collision is possible between the two same body, like same 2 blocks are colliding with each other. Any type of collision is possible between them. But with photon only 2 type of collision is possible. That's why if the electron has energy, electron beam has energy 12.5. So what will happen? some electron of the beam, they will transfer 12.1, some will transfer 10.2, means maximum energy what this beam can transfer 12.1. Okay, maximum energy this beam can transfer 12.1. Okay, so means electron will go to the higher orbit is what? Third. And now 3 to 1, what is the number of spectral line? 3. So in that case answer is what? 3. Maximum energy photon is that 12.1 in the emission spectrum. Should I repeat again? So what I said, when in the place of photon beam I am taking electron beam. So with two identical body, any type of collision is possible. So here what will happen? This electron beam will give maximum energy, how much it can transfer to the atom electron? 12.1. 12.75 it cannot transfer because it does not have. So maximum energy it can transfer 12.1. So higher orbit will be what? N2 is equal to third orbit, N1 is equal to 1. Then number of lines what we can say in the emission, that is equal to 3. Are everybody got or not? So difference between these two questions everybody got? Okay. So many things are there, but that is a basic of the atom that you have to know, and number of spectral line formula, Lyman, Balmer, Paschen bracket. Once all series, you know what is a lower shell, how we will find the energies and all in the chemistry as well as physics you have learned. Okay. Now come to the waves. So wave equation, everybody is comfortable. What is the equation of the wave, traveling wave equation? Like y is equal to a sine kx minus omega t. When kx and omega t have opposite sign, then wave travel in the positive direction. If the kx and omega t have same sign, means plus in between, then it will travel in the waves discuss beats topics are just wait. Then wave will travel in the negative direction. Kx and omega t, like kx plus omega t minus kx minus omega t. So kx and omega t have same sign, plus or minus, then it will travel in the negative direction. If they have the opposite sign, it will travel in the positive direction. This everybody know or not? Like I am saying y is equal to a sine kz minus omega t, kz plus omega t. What is the direction of propagation of the wave? I know that beats, maximum of you have the problem in the beats. I will come to that topic only directly. Minus x, where I use the x nalayek. Minus z. What we are using here, that is a direction. So we are using kz plus omega t. So we can say that dop is what? Minus z. Direction of propagation of wave is equal to what? Minus z. So most of you have the problem in the beats, because rest, like all equation formula based questions are there. Okay, so speed of the transverse wave in the string, v is equal to under root of t by mu. Okay, what is the velocity of the sound wave? What is the velocity of sound wave? Where you can do the mistake, that first I am pointing out. What is the velocity of sound wave? Anybody? That is a general formula of the wave velocity. That is not particularly for the sound. Omega by k, v is equal to f lambda. It is a general wave velocity. General wave velocity means it is applicable for transverse or a longitudinal. V is equal to f lambda. That we are using even for the electromagnetic wave also. C is equal to nu lambda. Okay. So V is equal to f lambda is the general formula of the wave velocity. Okay. We can use for any wave, any formula you mucked up, that you can equate with f lambda. Like velocity of transverse wave in the string, v is equal to under root of t by mu, that I can write is equal to f lambda. Okay. So f lambda omega by k, it is a what? It is applicable for general. It is a general formula of the wave velocity. Okay. Particularly I am asking for velocity of sound. I am saying the formula, you are saying the value. Now listen. Velocity of sound, general formula, like for any medium, general formula is the under root of b by rho. Under root of b by rho. Under root of B by rho. It is applicable for any under root. That's why I pointed out this particular formula, because I know that everybody mugged up the under root 3 RT by M, under root 3 RT by M. But under root 3 RT by M is the speed of sound in air or gas. Particularly air or gas only we are using under root of gamma RT by M. Under root gamma RT by M we are only using for air or gas. General formula for the wave sound velocity in any medium is the under root of B by rho. Okay, so that's why I pointed out here. So I can get the speed, sound in the liquid, solid or gas. For all medium, general formula is the under root of B by rho. Okay, where B is the bulk modulus, rho is the medium. Okay, particularly for air or gas, then Laplace formula we are using. Laplace said what? When the sound propagate in the medium, temperature, there is a no heat exchange between the surrounding and the sound. So then propagation of sound is adiabatic. So he took the adiabatic bulk modulus. Then for air or gas particularly, we are using under root of gamma RT by M. V is equal to under root B by rho is applicable for air or gas also. And B value we put the gamma into P. From that we got this formula. Okay. So under root B by rho is applicable for all medium. Okay. Which medium speed of sound is maximum? Which medium speed of sound is maximum? Which medium speed of sound is maximum? Solid, air, solid, air, solid, air, solid, vacuum. Wow. Who is saying in vacuum? Go to the vacuum, create the evacuated chamber and listen the sound. In the vacuum, speed of sound is 0, Nalayak. Because no any long sound wave is the long mechanical wave and longitudinal. Okay, so it required the medium for its propagation. So without medium, sound cannot travel. So speed of the sound in the vacuum is what? 0. Okay, so it is maximum in gas or air. Okay, now listen. Speed of sound order is what? Order of the speed of sound maximum in solid, then liquid, then gas. That is a good question for the NC like assertion reason. I will say so. Order of speed. Solid greater than liquid greater than gas, and velocity in vacuum. Velocity of sound in vacuum is equal to 0. Okay, so it is maximum in solid. Suppose I am saying velocity of sound is maximum in solid. Why? Velocity of sound is maximum in solid. Why? Somebody is giving reason: high density. Okay, if the density is high, rho is high, then the rho is high, then the speed has to be less. Who is giving the explanation? Velocity of sound is maximum in solid because density of the sound is high. So density of the sound is high, then what will happen? Rho is more, speed has to be less. But I am saying what? Velocity of sound is maximum in solid. Particles are nearby, yes, then it means density is more. Density is more, then rho is more. Rho is more, then velocity has to be less. Now listen. Okay, which medium is more elastic? Which low density? Solid has a low density. Nalayak, solid has a maximum density. Vacuum does not have density because vacuum is what? Nothing is there. So which medium is more elastic? Solid, liquid or gas? Which medium is more elastic? Solid, liquid or gas? Gas. Okay, gas. Okay, so elasticity is also the problem. Nalayak, listen first. Listen. Now I got your answers. Mostly you are saying the gas. What is the elasticity meaning? Elasticity is what? What elasticity word we are using from the childhood? That is not a elasticity. Elasticity is the opposite of that. Okay. So from the childhood, what we are doing? Like rubber we are stretching like this. Then we are saying rubber is very elastic. Okay. So in general talk, we are talking like this also. Means rubber is very elastic because we can elongate easily. But that is not an elasticity. It is a reverse of the elasticity, or we can say stretchable. Rubber is more stretchable. Rubber is more stretchable. Who is the more elastic? Who is more elastic? Who will oppose more? Who will oppose more? They are more elastic. Who will oppose more for the deformation? They will be more elastic. They will be more elastic. Like solid will oppose more for the deformation. If we are applying the force on the solid, liquid and gas, so solid will not deform easily. It will oppose maximum. So whose elasticity is maximum? Solid. Then liquid. And gas we can easily compress or expand. So gas is the least elastic. Minimum elasticity for gas, maximum elasticity for solid. Okay. So B is the what here? B is the bulk modulus of the medium. Now three medium: solid, liquid and gas. Bulk modulus means modulus of elasticity. Who is more elastic? Solid is more elastic. So bulk modulus is more for solid. So bulk modulus is more for solid, then liquid, then gas. Bulk modulus is more for solid, liquid, gas. Solid is more elastic than liquid, then gas. Okay. So B is more for solid. So B is in the numerator and B is the more for solid. Okay. So density B is more. That's why velocity of the sound is more. But this question will also arise. Sir, bulk modulus is more for solid. Okay. But density is also more for solid because liquid has very less density than solid, because and gas will have the minimum density in comparison to solid and liquid. So B more, rho more, both are the more and more upon more. Then who will be deciding factor? Okay, so B will be the dominant factor. B will be the dominant factor. Why? Because bulk modulus of water and steel, if you compare, so water is the order of 10 to the power 9, steel is the order of 10 to the power 11. So around 100 times more, and density will be around 5 times, 10 times more. Okay, so who will be the deciding factor? Bulk modulus. So speed of sound is maximum in solid, then liquid, then gas. What is the reason? Because bulk modulus of the solid is more than liquid than gas. Even solid has a more density, but bulk modulus is relatively more higher. That's why who will decide the velocity? Bulk modulus. Okay, this everybody got? One more thing about the solid. Suppose I am saying I'm ultrasonic sound and the audible sound. Ultrasonic sound means frequency is higher. So frequency is more. Suppose I'm producing the sound. I'm taking one source who is producing the ultrasonic sound, means high frequency, and who is producing the sound of low frequency. Which sound will travel faster in the air? Which sound will travel faster in the air? Ultrasonic or the audible sound or low frequency sound? Which sound will travel faster in the air? Ultrasonic sound means high frequency sound or low frequency sound? Which sound will travel faster in the air or vacuum? High frequency sound or low frequency sound? Low frequency, high frequency, low, ultra, high, ultra, high, low, high, low. Nalayak. Both will travel with the same speed in the air. Or so in the given medium, speed of sound is constant. In the given medium, because speed of sound doesn't depend upon general formula. We are taking f lambda, okay, for any wave. But first, if I am going through this formula, v is equal to under root b by rho. Bulk modulus is the bulk modulus of the medium. Okay, medium I am not changing, frequency I am changing. One thing. Density, rho is the density of the medium. Rho I am not changing. Okay, it means bulk for the given medium, bulk modulus and rho is constant at a given temperature. So whatever the sound you are producing, suppose you are saying the ultrasonic sound, frequency more, wavelength will be less. You are saying the low frequency sound, low frequency, wavelength will be high. But ultimately in the given medium, speed of sound is constant. That's why velocity of sound in air at STP we take 332 meter per second. Who is producing, what is the frequency, doesn't matter. Okay, even we have learned frequency of female voice is, the pitch of the female voice is higher than the male voice. But if they are producing the sounds, both will travel with the same speed in the air or gas. Why? Because in the given medium, speed of sound is constant. It will not change with the frequency or something. Okay, this everybody got or not? Okay, okay then. So in a given medium, speed of sound is constant. It will not change with the change in frequency, amplitude. Amplitude more means I am producing louder sound. Louder doesn't mean that faster. I'm increasing the amplitude means I'm shouting, suppose. So amplitude of my sound is high. Amplitude is high means energy is high. Energy is high doesn't mean that velocity is more. In the given medium, it will travel with a constant velocity. Okay. Last thing, suppose I'm saying air and here it is a water. Sound is traveling from air to water. Sound is traveling from air to water. Okay. Then what is the effect on speed of sound? Or what is the effect on the wavelength of sound? If the sound produced in the air, it is traveling to the water. What is the effect on the wavelength of sound? Wavelength will increase, wavelength will decrease, wavelength will remain same. If I produce the sound, some constant frequency, suppose I produce some frequency sound, okay, and then that sound is traveling from air to water, then what is the effect on wavelength? Increase, decrease, or remain same? Okay, remain same, decrease, decrease, same, decrease, decrease, increase, decrease, same. Now listen. We have learned what frequency depends upon the source. Suppose I produces the sound. So wherever the sound is going, once I produce the sound, frequency will not change, because this we have learned frequency depends upon the source. So throughout any other medium, suppose I produce the sound, whatever frequency I produce, suppose I produce the frequency F. Now it is going from air to water to solid. Wherever it is going, frequency will not change. Okay. Generally what happened, we are habituated for the light. So when we are saying the light wave is going from the rarer to denser, then wavelength decreases, velocity, speed decreases, frequency remains same. But in the case of the sound and light, the case are reverse. Why? Light has the maximum speed in the vacuum. But in the vacuum, what is the speed of sound? 0. Okay, light has the maximum speed in vacuum. In solid, light speed will decrease. Light speed will be minimum. But in the sound, it is a reverse. In the solid, speed of sound is maximum. So whatever we have learned in the ray optics, that we will not apply for the sound here. Are everybody got or not? So when the sound is going from air to water, so we know that solid maximum, then liquid, then gas. So air to water it is going, so speed will increase. Wavelength will increase, but frequency remains same, because frequency depends upon source. Everybody got? I am pointing out those things where you can do the mistake. Okay, it's a theoretical question and they are asking. Okay, up to that everybody got? Okay. Now beats. What is a beats? So basically we have learned the superposition. Superposition principle we are using. Won't depend upon the refractive index. Okay, Safia, what is a refractive index? Can you define what is a refractive index? Can you define what is a refractive index? Somebody says that it doesn't depend upon the refractive index. I am asking, can you define what is a refractive index? Except that its symbol is mu. What is a refractive index? C by V. It is a formula. Okay. To me, it is a medium. So one thing, you are in the class 12th, at least you have to open the NCERT sometime, because in the 11th and 12th, you have the time to read the NCERT if you have not read the definition, and you are going to write the board exam also. Okay. So refractive index is what? It gives the idea about the optical density. Refractive index is what? It gives the idea about the optical density. Optical density and density are the different thing. Density more, optical density more, we cannot say. So refractive index, we have introduced one quantity that gives the idea about the optical density. What is the meaning of optical density? A medium will be more optically dense, in which light travels slower. And the medium will be less optically dense if the light travel faster. Again, I am repeating. What is a refractive index? It gives the idea about optical density of a medium. What is the meaning of the optical density? The medium in which light will travel faster, it will be less optically dense. In which medium light travels slower, it is more optically dense. So I can say which medium is the least optically dense? Vacuum, because light travel, maximum speed of the light is in the vacuum. Okay, everybody getting or not? So refractive index we defined only for the light, optics, light we have defined. We have not defined for the solid. Safia, got or not? So refractive index we will not talk for the solid. Refractive index we define only for the light. That's why mu we have directly learned in the ray optics. Okay. Okay then. So what is a beats? Beats means what? Basically superposition was first thing. What is a superposition? So superposition is what? When we are using in Newton's law. Suppose any particle, 10 forces are acting. Then what is the net force on the particle? So we will say what? Vector F1 plus vector F2 plus vector. We will add all forces. So that is our superposition. Suppose in the gravitation, 10 masses are there. You are finding the field at any point due to the 10 masses. Then what we are doing? I1 plus I2 plus I3 plus I10. That is about superposition. So basic mathematical simple meaning of the superposition is what? Addition. Okay. This everybody got. Now in the beats, what is happening? So what is the condition of the beat? So when we are taking the suppose two waves of two or more than two waves also we can consider. So when two or more waves of different frequency or nearly equal frequency, in NCERT they give a nearly equal. Why? Normal human being if I am talking about, so we cannot identify more than 10 beats per second. So we can only differentiate up to the 10 beats per second. More than that we cannot. That's why beat, what is a beat? It is a superposition of the nearly equal frequency. Then in the beats, what will happen? Suppose I am standing here. Two sources are there. They have the slightly less different frequency. And their sources are producing the sound. Okay. The sound is reaching to me from the different sources, and they have slightly different frequency. So when the sound is reaching to me, it is then due to the superposition at me, I will say what? Y is equal to Y1 plus Y2. So due to the superposition, what will happen? Sometime I will hear continuous sound. In between, sometime I will hear very loud. And then low, loud, lower, loud, low, loud, low. Like this will happen to me only. In continuous sound, in between high, low, high, low, high, low, I will hear. So that is the beat. Beat means what? Number of maxima or number of minima per second. Means you are hearing the continuous sound in between, sometime maximum, sometime minimum. So in 1 second, how many times maxima or how many times minimum? They will be equal. How many times maxima or how many times minima you are hearing? That is called the beat frequency. So what is the beat? It is a superposition of the two waves of nearly equal frequency. So at any point, at the same point, what will happen? Intensity will change with time. In between a continuous sound, sometimes intensity is higher, sometimes intensity is lower. That is called the beats. And what is the beat frequency? Number of maxima or number of minima per second. Number of maxima, either you can count, or number of minima, because both will be equal. So number of maxima or number of minima per second is called the beat frequency. Okay. Mathematically, beat frequency is equal to what? Mod of F1 minus F2. Okay. So difference of the frequency of the two sources, that we will take as a beat frequency, like 10 and 12. Then what is the beat frequency? 2. It means we will hear 2 maxima and 2 minima per second. So what is the time interval between consecutive maxima? 1 upon beat frequency. So suppose I am hearing the 2 maxima in 1 second. So what is the time interval between consecutive maxima? 1 by 2. Consecutive maxima 1 by 2. Consecutive maxima and minima, then 1 by 2 into 2. Why? Maxima, minima, maxima, minima, maxima, minima. It will be alternate. maxima to maxima or minima to minima, 1 upon beat frequency. Okay, but I'm saying maxima, minima, maxima and minima consecutive, then it will be the half of that time, means 1 upon 2 into beat frequency. Okay, like this type of. These are the maxima. Okay, these are the minima. When I'm saying consecutive maxima and minima, this maxima to maxima, 1 upon beat frequency. If I'm saying maxima to minima here this time, then I will say what? 1 upon 2 into half of the this. Na? So 1 upon 2 into beat frequency. So consecutive maxima if I'm saying, so consecutive maxima I'm saying, so 1 upon beat frequency. Consecutive minima I'm saying 1 upon beat frequency. But I'm asking consecutive maxima and minima, then it will be what? 1 upon 2 into beat frequency. This everybody got or not? Completed? This graph meaning is what? How this graph came? Okay, what it represent? Already in the 2000, I think 22 or 23, they asked the question based on this graph in the JMIN, and exact same question, same example given in NCERT in the beats, first page of the beats. Okay, so what is the meaning of this graph? Suppose I am saying I am taking the two sources of frequency. I am taking the same example of NCERT, 11 Hertz and 9 Hertz. Okay, two frequencies, 11 Hertz and 9 Hertz, they sounded together. So first thing, if I'm asking how many beats per second, so what is the beat frequency? I will say what? 11 minus 9, that is equal to 2 Hertz. Okay, so beat frequency is 2. Okay, now beat frequency is 2. It means we will hear 2 maxima and 2 minima in 1 second. 2 maxima and 2 minima in 1 second. Now they ask what? If the two sources of the sound of frequency 11 and 9 sounded together, which graph represent the variation of intensity? Which graph represent the variation of intensity? Only two options I am giving. Suppose this two option I gave, and I'm asking which graph represent the variation of intensity, first one or second one. Only two option I'm giving. Data I gave the same. Frequencies of the two sources are 11 Hertz and 9 Hertz. Now, which graph represent the correct variation of intensity? Now listen, answer is not one, answer is the two. Now listen why. Because first thing what I got beat frequency is the 2. Beat frequency 2 means what? We will hear 2 maxima and 2 minima in 1 second. In one maximum, how many? 1 second, how many maxima? 2. And how many minima? 2. Okay. If you are getting confused to count from the maxima, just confirm from the minima also. Okay. What I said in the beats, in a continuous sound, in between high and low will be there. High and low will be there. Okay. Now here you can see. If I am asking how many maxima I am hearing here, I gave the time is what? 4 seconds. So we start counting maxima. This is representing the continuous sound in between high, low, high, low, high, low, high, low. This also there. Okay. 1, 2, 3, 4. 4 maxima or minima if I count 1, 2, 3, 4. This I will count in the next cycle. So 4 maxima or 4 minima in how much time? 4 seconds. So what is the beat frequency according to this graph? 4 maxima up in 4 seconds. So per second how many maxima? 1. So according to the first graph, what is the beat frequency? Beat frequency according to the first graph is 1. Okay, because we are hearing 4 maxima and 4 minima in 4 seconds. So 1 second how many maxima? 1. So what is the beat frequency? 1. But in the second graph, if I count the maxima 1, 2, 3, 4 or minima 1, 2, 3, 4. So 4 maxima or 4 minima, okay, in 2 seconds. 4 maxima or 2 minima in 2 seconds. So beat frequency, what I can say? Beat frequency is equal to 4 by 2, that is equal to 2 hertz. Now, what is the beat frequency? 2. And how many beat frequency we want? 2. That's why what is the right answer? Second one. Everybody got? This is the variation of the intensity when the two sources of different frequency are sounded together. It's about what I am not getting what you are asking. Completed? Somebody was asking something. Okay, so one question I will discuss on the beat means like I will consider take the organ pipe. Okay, and then tuning fork question you want. Then I will discuss the tuning fork. No organ pipe, I will discuss about the tuning fork. Tuning fork, okay then. So, no sir, organ pipe, no. If you ask the option, then the infinite options will come. Okay, so similar problem, whether I'm saying for the organ pipe and whether I'm saying for the tuning fork, both problems are similar and same solution is there. Only in the organ pipe, they will change the frequency by changing the length, means because we know the organ pipe frequency is the V by 4L and V by 2L. And in the tuning fork, they will change the frequency by loading or filing. Okay, I will combine both. One question I will discuss. Okay, by combining tuning fork and organ pipe, one question I will discuss. In that, both I will use. Okay. First thing, what I'm saying, fundamental frequency of closed organ pipe V by 4L. Fundamental frequency of open organ pipe is what? V by 2L. Okay, where V is the speed of sound. V is the speed of sound. Okay, in the tuning fork, when we are adding any mass, loading, we are calling it as a loading. Sometimes they will say loaded with wax, loaded with tape. When we are adding the mass or loading the mass, frequency of tuning fork decreases. Okay, so when you put something on some load on someone, then what will happen? Their motion will get what? Decrease, we can say. Then frequency decreases. Like that way you can remember. Loading decreases the frequency of tuning fork. Filing means rubbing, basically. When we file something, rubbing. So filing will decrease the mass. So we can say filing increases the frequency of tuning forks. Loading increases the frequency of tuning fork. Filing decreases the frequency of tuning fork. Okay. So, okay, one question I will discuss first from the tuning fork. Then I will discuss the organ pipe, one question. Suppose I give this question. two tuning fork A and B sounded together and 4 beats per second are heard. If A is filed, then beat frequency decreases. Then we have to find the frequency of B. Okay. Always any beats problem, always first we will write the possible frequency. That is the first step in all the beats problem. Always we have to write the, somebody saying 204, somebody saying 196, only two answers are possible, and somebody saying both. Okay. So what I said, in the beats problem, first we have to decide the possible frequency of unknown, okay. That will be the first step in the beat problem. After that, they will give some extra condition. From that, we can decide what is a unique answer. Okay. Whatever I am going to say, in this way, one option we will reject. Suppose you write the two possible frequency of unknown, F1 and F2. Suppose I am saying F1 is not the answer. I am getting the frequency of, first listen now, don't give the answer. I am saying what? F1 and F2, two frequencies, I am possible frequencies for the unknown. If I am saying F1 is not the answer, then what is the answer? If I am saying F1 is not the answer, two possible frequency possible are F1 and F2. F1 is not an answer, then what is the answer? F2. Okay. And so if I rejected one option, then other answer I can say this is the answer. And that answer you will verify. That answer we can verify also. It means beats problem we can verify our answer 2 times. So after verifying 2 times, if you are doing the mistake, it means now it is a blunder. So what we will do in the beats problem? First, we will decide the unknown frequency, 2 possible value. Okay. First, we will decide one frequency of possible frequency of unknown. Okay. Then one option we will reject. One option is we will say it is not possible. If I rejected one option, then answer we got. Okay. And that answer we will verify. Okay. So first step is what? Possible frequency of unknown. Here A and B sounded together. How many beats we are hearing? 4 beats per second. A I gave 200. Frequency of A I gave 200. Then first I will write possible frequency of unknown, means FB. It will be what I said. Beat frequency is the difference of the frequency. Beat frequency is the difference of frequency. But I don't know B is more or A is more. That's why possible frequency of B, 2 possible answer. 200 plus minus 4. Maybe B is more by 4 or less by 4. Only these 2 possibilities are there. Either it will be more than 4 or less by 4. So 204 or 196. It means any 2 answer they given, other answer then directly we can neglect. Either answer is 204 or 196. Okay. What I said, one we will reject, one we will verify. So answer we will verify 2 times. Now what we will do, we will consider these 2 frequencies. First, we will take one frequency, we will verify it. So by loading and filing, they will say sometime also small loading is small filing. So we will not change the frequency more. We will change the frequency by small amount, like 1 Hertz, 2 Hertz, 0.5 Hertz to check only our answer. Okay. So suppose I am taking frequency of B is 204. First I am taking 204. Okay. I am checking 204. Then A frequency was 200. Okay. When they sounded together, how many beats? 4. Okay. Now what I am doing, I am filing the A. Then I am saying beat frequency decreases. Okay. So what I will do, I will file A. When I will file A, suppose frequency of A become, filing increases the frequency. What I said, we will change by small amount. Suppose it become 201. It become 201 Hertz. Okay. Now when I am sounding 201 with a 204, how many beats produce? 3 beats per second. So it increase or decrease? Earlier 4, now 3. So in the question what I gave, beat frequency is decreasing. So it is verifying our condition or not. What I said, when I file A, suppose we will change by small amount. So after filing, frequency of 4 increases. So suppose it become 201. Now 201 and B have not changed anything. B is the 204. 204 and 201 sounded together. How many beats? 3 beats. And they in the question also they are saying after filing A, beat frequency decreases. So it means 204 verifying. So we got 204 is the answer. 204 is the answer. Now we will reject 196. Then our answer will get verified by 2 times. 196 I have to reject. Then only I can say it get verified. If the frequency of B is the 196, because we don't know na. So I know that I started with 204, but maybe you started with 196. Okay. So if it is a 196, and after filing A become 201, then when they sounded together, beat frequency is the 5. So it increased. But in the question what they said, beat frequency decreased. So it cannot be the answer. So what is the answer? 204. Completed? Okay. Now one last question. What is the meaning of resonance? Resonance means when the frequency of two vibrating bodies are equal, then that condition is called the resonance. In detail, I'm not going. I think you know, everybody know what is a resonance. Resonance means what? When the frequency of two vibrating bodies are equal. Okay. So suppose I am saying, suppose I am saying two closed organ pipe of length 50 centimeter and 52 centimeter, 50 centimeter and 52 centimeter. They sounded together with a tuning fork, and both are producing 10 beats per second. Both produces 10 beats per second with the fork. Then we have to find the frequency of the fork. Okay. So here how many total bodies are there? 3. Two organ pipe and one is the tuning fork. Okay. I'm asking the frequency of fork. So whatever the unknown they are given, that unknown first we will assume. So they are asking what frequency of fork. So suppose I assume frequency of tuning fork is equal to F0. I assume because they are asking, so I assume the frequency of tuning fork is F0. Okay. Now how many organ pipe I have? 2 organ pipe. Okay, 2 organ pipe. Now 2 organ pipe. When they sounded together, what I said, when they sounded with a tuning fork, how many beats produce? 10 beats per second. Last question. 10 beats per second. 10 beats per second produce. Okay. So then I'm asking what is the frequency of fork. Both are producing 10 beats. So what I said in the beats, first we will write the possible frequency. If this fork is producing 10 beats, so unknown frequency possible is what? F0 plus minus 10. Either unknown frequency, either it will be F0 plus 10 or it will be F0 minus 10. Okay. Everybody getting or not? So first we will write the possible frequency of known. It will be either F0 plus 10 or F0 minus 10 if I took the frequency of fork is F0. Okay. But in the question they are saying both organ pipe are producing the 10 beats. It means, okay, both same tuning fork, one is producing 10 beats, other is also producing 10 beats. I have the 2 fork, so one will have the frequency what? F0 plus 10, other will have the frequency F0 minus 10. Then only both can produce the same beats with F0. So suppose one organ pipe has F0 plus 10, other organ pipe has F0 minus 10, then only they can produce, both will produce the 10 beats with the fork or not. So one frequency will be what? One organ pipe has frequency F0 plus 10 and one organ pipe will have the frequency F0 minus 10. Then they can produce the same beats. Okay. Now which will have the F0 plus 10, which will have the F0 minus 10? Frequency of the fork we know, organ pipe V by 4L, V by 4L. It means V inversely F inversely proportional to L. So whose length more? Frequency less. Less frequency, more length. So suppose this is the F2 I am taking. So L2 will be what? 50, less frequency, more length. So means 52 centimeter. Here more frequency, less length. So L1 what I will take? 50 centimeter. Now you can say what? F1 upon F2 is equal to L2 by L1. From this you will get the frequency of unknown. Okay. Completed. If anything is remaining, then now you can ask in study hour. We will meet in the campus. Okay. Okay then. Bye bye. Happy Pongal to all. Bye 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 bye.